Hello and welcome back to my channel. So we're looking at the fourth part of our series. And so before we look at the optimization procedure that we can adopt here, let's look at the way we could display these values in tables. So if you go to this toolbar, we could click on this and we can either generate tables for the nodes or the links. So because we're dealing with the pipes for now, so let's look at the links, and then you see table has been generated. And so if you look at pipe 1, the value of the velocity is 0.85, which is showing here. And also for pipe 2, the value is 0.61, which is showing here. And so all these readings that have been generated as a result of the simulation have been tabulated. And so we can determine the unit head loss. We can also determine the friction factor and also the reaction rate. And the flow is given here. So the negative sign shows that the flows are moving in opposite direction. So let's explain a few things. The criteria that can be adopted for the various parameters. In this case, we're talking about the pipe sizes, the velocity, the pressure, and so on, are dependent on standards of a given municipality. And so what obtains in Canada may be different from what obtains in other countries. And so for this video, let us assume that we have for velocity an average working velocity or operating velocity of between 0.6 to 2.5 meters per second. Now what this means is that any value below 0.6 or above 2.5 will not be allowed within the distribution network. That means that adjustments will be made so that we can come up with values that at that stage we will regard as being optimized. And then we also consider pressure, because for this video we shall focus on both the velocity and pressure, and we shall look at the relationships between them, and we shall look at how it applies to this network scenario. And so for the average operating velocity, we are going to adopt values between, let's say, 250, or let's say 200 to 300, or let's take it as 250 to 300 kilopascals. Now there's something else I'll need to tell you. Let's look at the pressure. So let's go to nodes and then click on pressure. Now what you can see here is that we have at junction 1 16.62. Now what that means is that we are not dealing with pressure in terms of meters. Now we can convert this by multiplying it by the acceleration due to gravity. And so let's bring out our calculator and let's try and solve. So let's say 16.21 multiplied by 9.81. So this will give us a value of pressure in kilopascal. So what this means is that we're actually having a low pressure situation here. And what it means is that this value should be about, this value is about 159 kilopascal. Now this means that from the conditions we adopted, that it should be between 250 kilopascal to 300, meaning that we need to increase the pressure. Now there's something else we must understand. The relationship between pressure and velocity is such that high velocities usually lead to pressure drop, while lower velocities can result in pressure increase. Now, there's something else we must understand. They are also related to the pipe sizes. And so let's look at the pipe size of this pipe 2. And let's see, we can see that the diameter is large. So what happens if we decide to reduce it to, let's say, 200? And let's run our simulation. Now, remember, the pressure is 16.21 meters, while the velocity is about 0.78. So what this means is that it's just slightly above the average operating velocity. So let's reduce this, and then let's run. We have reduced the pipe size. So let's run the simulation again. Now let's look at our values. So what this means is that you can see our velocity has increased. So what happens to our pressure? Our pressure was 6.21. So we have increased our velocity. Now what happens? What else can we do? Let's look at our... So what happens when we when we reduce our elevation? Let's see what happens. Or let's reduce to 39, and let's so if we decide to reduce the elevation from the previous value by about 2 to 3 meters, we could see that the pressure increased. So if we multiply this, you'll see that 19.21 times 9.81 should give us up to 188.